I was practicing this yesterday or the day before, and it made a false alarm. Some of you I know saw. I've been wanting to make more videos again, so I thought, well, check this thing out. I'm going to use this, and I thought maybe I'd teach a little programming, but it's so weird. I should start a separate channel, but I just don't have the energy for that. But I might start by playing with these great things, IPython notebooks. I think Hythloday might be interested in these. So first subject here. So I was thinking of using these notebooks. You run a little local web server and you can make a notebook. So this episode 1 here with the notebooks is, first of all, Python notebooks themselves. See, that's how notebooks work. This is the markdown. This is what it looks like rendered. So we're going to talk about quantum theory and slander, phantasm theory, and also the honesty of society as a little bonus. So first of all, IPython notebooks, which is what you're looking at here. Okay, so you can have markdown. See, that says to do headings, you know, like regular old wiki markdown. But also these ones down here, they're Python. Let me delete all the output. Okay, so if you see, this is Python that says get raw input, which means, you know, let somebody type something in and then print something with that raw input. So I'll execute it by hitting Shift Enter, and I'll say, hello, Craig, right? Or down here, this will just print numbers 1 to 20 and so on. You know, whatever Python you want to have. So a cool thing too is the math formatting. Oh, did you see that? In these, in addition to having this kind of formatting with this sort of thing, and I could say this will be bold, I think, and this italic, right? And also format math. So here's some math. This is how you describe it, the format language. And then here's what it looks like, right? So you can do fancy mathematics. This is a good example. See that C equals square root? You get to do square root this way and use the curly braces so it knows where to put things and how long to draw the line. Same thing with fraction. So I like that. Plus it's got, so you can do things. This is LaTeX inline. Knows love that. All right, and then also here's with Matplotlib, which is a plotting thing, and Pylab brings in NumPy as well. So here I'm just going to plot something, some random numbers. So what I'm plotting is, well, let's do this in 2 steps. So let's first just plot this. So X is from 0 to 100, as you can see. And then by steps of 0.01, this is something NumPy has. See, import NumPy as MP. And then MP, so this makes X a big vector, right? With what, 1,000 or 10,000 elements. Y is NP to the power. That means take every exponent here and put it to the power here. If this was a vector, the exponents could be different, but since it's just a scalar, it's going to put everything in X to the squared. So this is the same as saying y equals X squared, right? And so you see you get a little bit of a parabola, part of a parabola. Okay, now plot 2, I am multiplying y times the sine of x, and then I'll plot that as well. I just uncommented that, and we'll get both plots. I mean, Matplotlib is just great. See? So let's do that to 1,000. Let's see if that makes it take very long. So, and so on. Yeah, Matplotlib is lovely. Okay. Now on quantum theory. Now the thing is, Hythloday and Gary are both, well, Gary mostly, but then Hythloday seemed to back up Gary a little bit and is bad-mouthing him some people I respect. Now, you don't have to respect them, but I respect them, so I object. It has to do with the path detection and double slit experiments. And, you know, it has been done. And for people that can't quite wrap their heads around it, it's basically like this. You know, there's ways to figure out which path the photon took. And they've tried a lot of different ones. You know, in photons, there's crystals you can put in front of the slits. And for electrons, you know, it's an electrical charge, so you can detect it going by. It'll wobble the electromagnetic field, you know, and you can detect that. And if you do those detections, any amount of detection is enough to, you know, so-called collapse the wavefront, you know, get rid of the interference pattern. Now, with erasure and stuff, I think that the most clever way is, what if you do this? What if you fire your light source and it puts out photons of various polarity, and in front of each slit you put a polarizing filter, so only light of certain polarization is going to go through it. Now remember, when a photon is shooting you know, from east to west, you can imagine it's got a polarization where it's also wiggling, like the wave is wiggling up and down, let's say, or wiggling east, north, south, or somewhere in that, you know, rotational zone, right? So when one hits the filter, if it has the right kind of polarization, is the same as the filter, it's aligned with the filter, it can get through. And then if you have a detector that can detect the polarization as well, then you'll be able to tell which slit the photon went through, so long as you could put polarization filters in front of both slits and rotate them at 90 degrees, right? So you can tell that when you detect a photon of a certain polarization, you know, left, right, or up and down, that it went through one slit or the other. That will destroy the interference pattern, right? Now, the interesting thing is that you can rotate one of the polarization filters so that now they're aligned, and suddenly you don't know which slit it went through again, but you still have the filters in the way, right? So the filters are in the way, but you get your interference pattern back. Therefore, you know, it's not the fact that the filter is in the way that causes a problem with the interference pattern or collapses the wave front, so to speak. It can't be, because you can have the filters in the way, and as long as they're not aligned such that you extract information, it doesn't matter. What you have really is this chain of information being demonstrated as the primary physical characteristic. You know, that whether or not the photon goes through a detector apparatus doesn't matter if the apparatus doesn't have, you know, isn't aligned in such a way as to yield information. So I think that says a lot. So now phantasm theory is this idea that I've been working on where, you know, I think single-celled organisms are basically have this phantasm. A phantasm is one of the many words we have as for a synonym for perception. And it's the most vague one. It implies you don't really know what it is that you're perceiving, and it wafts by, and it can be any of the five senses or any combination of them. It's generally a combination or associated with a feeling and so on. And I think that we see this phenomena through willful behavior. And I believe I can demonstrate that through a reductionist argument where basically what we have is, we know since we ourselves are colonies of eukaryotic bacteria, or well, not bacteria, but eukaryotic single-celled life forms, um, we know that somehow the fact that we perceive phantasmagorical, we have sense spaces in which information seems to waft through, that somehow in our components as a colony of these single-celled life forms, the phenomena will be expressive of that. It'll somehow, emerge. And I think the question is, I'd like to think of two models of emergence. One kind of model is fire, the emergence of fire. And you know that in the wood and paper and matches, all the energy that you're going to release, it's already in there, but it's basically dormant. And you have to start a chain reaction, and then you have the phenomena of fire. Now with life, with the other example is a different kind of emergence, is with magnetism. With magnetism, all the little atoms are little magnets. And it's not so much that the magnetism is dormant, it really is fully active at all times. It's just that it's not aligned. The neighboring molecules are pointing in different directions, so the magnetism doesn't line up. It's unamplified. But you don't say that the fire is unamplified in the wood that hasn't started burning yet. It's rather, it's in a different form, and the chain reaction of releasing fire changes that form. So, I don't know if the phenomena of having phantasmagorical personal reality, I don't know if that is more like fire or more like magnetism, right? I think we can see that phenomena starts at all life, and at least life that displays the behavior of life, right? You have something like a virus when it's in the wild and it doesn't seem to behave alive. It seems like it's in a dormant state. But when it does get inside a cell, and it acts with this way of life, and I believe that's where the phenomena at the very least starts. So if phenomena is like a fire, then life is, once the fire is started up and going, the engine is running. It could be that, like Hameroff says, that it goes down to particles and is a quantum phenomena in the most basic sense. Clearly, what we think of consciousness is related to life, and the need to survive, and all the artificial needs that a living machine presents to this subjective phantasmagorical entity. The last thing is just that, I think in a way I live at the wrong time where people aren't very honest. And I was thinking kind of the geeky, nerdy population supposedly isn't good at socializing. And I think, that might just be because they're honest. They tend to be honest. And this is not a socially rewarded behavior. And that's fine. But I just think I might be in the wrong time, in the sense that I really would just I think the society will get a lot more done, a lot more efficiently, in a more emotionally efficient way when it's in the future, in the distant future, when it's generally honest. All right, cheers. Let's see how that worked.